All right, today we're going to talk about relative dating. So relative dating is when we find the age of a rock relative to the rocks around it. So we're comparing the ages of rocks in one setting. We can compare it sometimes with other settings, but we definitely are comparing them. We don't know the exact age, we know about its age or approximate age. So words you want to keep in mind are the principles. So you have superposition. Superposition says the youngest should be on the top and the oldest should be on the bottom. So that means we're forming things in layers and we're adding on top to each year, or over millions of years in the Earth's case. And every layer should get younger as you go up. Cross-cutting says that things like faults and intrusions or plutons that cut across sedimentary layers are younger than the layers they cut across. And then last but not least, well, second to last but not least, horizontality just says that our sedimentary layers should be horizontal when they deposit. They would not form at an angle. So that means if they are at an angle or they're bent, they've been changed by some other action that happened to those layers. And then uniformitarianism is a big word for a simple idea. It just says that things going on today are happening the same way they happened millions of years ago. So sedimentary layers still form today. They would have, millions of years ago, back when the crust was first forming. Other little helpers we're going to keep in mind are index fossils and key beds. So index fossils, let's take a little look over here at my drawing, which is excellent as usual. So we have several fossils. We have a snake fossil in red here, and it's in a couple layers. We've got my fish fossil in black, and then we have my bunny fossil in blue. Which one of those would be an index fossil? Well, we'd have to see more than just this one outcrop, but the best contender right now would be the bunny, because it existed for only that short period of time in the one layer of rock. If that bunny were found all over the world and many rock outcrops similar to this one, it would be an excellent index fossil, because it's world spread or widely spread, and it only existed a short period of time. Now my key bed would be my little example down here with the little diagonal lines. And it says in the corner there, ash from a supervolcano. A key bed is a distinct layer in the rock record found, all over the world in a lot of cases. And it indicates something that we can find the absolute age of, like ash from a supervolcano. We can go and take the ash and use absolute dating, which we've talked about before, to find out the exact age of that rock, and then use it to determine the relative ages of the rocks around it. So a key bed is often found all over the world, or sometimes in just a small area, but we can obtain its absolute age, so exactly when it happened, to help us figure out what some of the other things that happened around it, how long ago they happened. So with relative dating, just keep in mind, you want to understand your principles and how we would use them. We want to keep in mind things like in our little picture here. So in my picture, this should be my youngest layer. My bottom layer should be my oldest layer. Now, this dark spot would be an intrusion, so cross-cutting would apply. This layer is younger than the layers it's on top of, or it cuts across. So it's even younger than my key bed. We would know that this happened after my key bed was deposited. So if I knew exactly when this was, we would know this would be less. So that would be my cross-cutting. Now notice my layers are horizontal. They have not been diagonal or bent in any way. They're horizontal, so my horizontality is applying here. And again, all of the principles that we see today are applying now, like uniformitarianism. So erosion happens the same as it once did, and deposition happens as it always has.